Okay, let's start with this problem. Square root 82, raise it to the 23rd power, and 3 raise it to the 46th power. We want to see which one is larger. So what we're going to do is we're going to leave the square root 82 to the 23rd power alone, and then I'm going to take 3 to the 46 and take out a 2 from 46. So if we take out a factor of 2, that means 23 remains. And we know that an exponent to an exponent, you multiply. So I'm allowed to do this. The next thing, okay, let's leave square root 82 to the 23rd power alone. And then 3 squared is 9. And then we have 9 raise it to the 23rd power. Again, I'm going to leave the square root 82 to the 23rd power alone. And I'm going to rewrite 9 as a square root of 81. And then that will be to the 23rd power. So notice with these two square roots, we have both, they have the same exponent, but the square root is different. So the base is different. This base is bigger, so we say that square root 82 to the 23rd power has to be bigger than the square root 81 to the 23rd power, which if we follow back up here would take us back to 3 to the 46th power. Okay, let's look at a more complicated problem. Let's look at 2 raised to the 3 to the 4th power, 2 to the 4th cubed, 3 to the 2nd to the 4th power, 3 to the 4th squared, 4 to the 2nd cubed, and then 4 to the 3rd squared. Notice with these problems, we have basically two exponents. One, the 4 here is the exponent of 3. So you can think of that as 3 to the 4th. So that's going to be the first thing that we do. So we're going to leave 2 alone, and then we're going to evaluate 3 to the 4th. Well, that's 3 squared squared, which is 9 squared, and so that's 81. We're going to do the same thing with 2 to the 4 cubed. We're going to say 2, and then 4 cubed is 64. And then 3, 2 to the 4th is 16. 3, 4 squared, that's also 16. And then 4, 2 cubed, well that's 8. And then 4, 3 squared, that's 9. Notice for most of these, the base is a nice prime number. So let's get all prime bases. So I'm going to leave the first couple alone, and then I'm going to change the last two. So 4, we can rewrite it as 2 squared, and then we'll just raise it to the 8th power. And then same thing here, 4 is 2 squared, but we'll raise it to the 9th power. Let's rewrite it. We have 2 to the 81st, 2 to the 64th, 3 to the 16th, 3 to the 16th, and now we have 2 to the 8th, that'll be 16, and then 2 to the 9th, that's 18. Our goal here is to find the biggest number. So the strategy is, let's find the highest exponent with base 2, and let's find the highest exponent for base 3. And let's make the comparison. So the highest exponent for base 2 is 81. The highest exponent for base 3 is 16. Okay, so we narrowed it down to two numbers. Now, let's consider 2 to the 80th power. So going from 2 to the 81st to 2 to the 80th, we divided by 2. So in other words, we got smaller. And now let's leave 3 to the 16th alone. On the side here, let's look at the GCD of 80 and 16. So the greatest common divisor of both 80 and 16, that happens to be 16. So I'm going to raise both sides to the 1 over 16th power. So in other words, I'm going to be taking the 16th root to both sides. And the reason I'm going to do that is because an exponent to an exponent you multiply. So these numbers will multiply to a very nice whole number. So 80 times 1 over 16 is 5. And then 16 times 1 over 16 is 1. So I have 2 to the 5th and 3. Well, obviously 2 to the 5th, well, that's going to be 32. And then that is definitely greater than 3. So not only did I divide by 2 to get to a smaller number, so I divided by 2 here, my result was still bigger. So that means if I go back along this line, so if I go up here, this is bigger, and because I divided by 2, this is also bigger, since 2 to the 81st power is twice as big as 2 to the 80th. So we can conclude that 2 to the 81st power is the largest number, which was written as 2 to the 3 to the 4th power. Okay, let's look at a more interesting problem. Let's say if we have 63 to the 45th power and 33 to the 54th power. We want to see which one is larger. So the strategy to this is, let's first find the GCD of the exponents. So let's look at the greatest common divisor of 45 and 54. So that will be 9. So that's going to be the radical, or the exponent, that we're going to be raising it by. So it'll be 1 over 9 in this case. So we're going to raise both sides 1 over 9. The 63, and then 45 times 1 over 9, that's 5. And then 33, and then 54 times 1 over 9 is 6. Okay, so now we simplified it to a little more friendlier numbers. But there's still some work left to be done. So let's break up 63 and 33 into prime factors. So 63 is 7 times 9, which 9 can be represented as 3 squared. And then we're going to raise that to the 5th power. And then 33, we can say, well, that's 11 times 3, and we'll raise that to the 6th power. I'm going to distribute this exponent to both the 7 and the 3 squared, and then the 6 to the 11 and the 3. So 7 to the 5th times 3 squared to the 5th power, and then we have 11 to the 6th times 3 to the 6th. So we're left with 7 to the 5th. Exponent to an exponent we multiply, so 2 times 5 is 10. And then we have 3 to the 6th times 11 to the 6th times 3 to the 6th. I'm going to divide both sides by 3 to the 6th. So I'm going to be left with 7 to the 5th times 3 to the 4th. And that's going to be 11 to the 6th to the other side. I can then, let's see, I can pull out a 7. So it'll be 7 times 7 to the 4th times 3 to the 4th. And then I can break this up. 11 to the 6th could be 11 squared times 11 to the 4th. Okay, there's a reason why I'm going to do this, because I'm going to want to bring everything under the exponent of 4. So let's see. This 7 and 3 that we're multiplying here, we can get it all under the 4th exponent, so the power of 4. So let's see how that's going to look. So we can say 7 times 3 raised to the 4th power, and then we'll have 11 squared times 11 to the 4th power. Now 7 times 3 is 21, that'll be 21 to the 4th, and then 11 squared times 11 to the 4th. I'm going to move the 11 to the 4th over here by dividing it, and I'm going to put the 7 to the other side. So divide the 7 over. So that means I have 21 to the 4th over 11 to the 4th, and then I have 11 squared divided by 7. And then I can think about factoring out the 4, so it'll be like 21 over 11 raised to the 4th. And then it's 11 squared, which is 121 over 7. So 121 over 7, that's approximately, let's see, well, that's 1, then 7 times 14, well, 7 times 12 is 84, 7 times 14, 98, so we need a little more. I think it's 7 times 17 is 119. So it's like 17 and I think 2 7s. So I think this is exactly equal. And this, let's look at a bigger number. Let's look at 22 over 11, right, to the 4th. And then we'll just leave 17 over 2 7s. So this will be 22 divided by 11 is 2 to the 4th. And then this is just 17 and 2 7s. 2 to the 4th, that's 16, and that's 17 and 2 7s. And notice 17 and 2 7s is bigger. So not only over here did we find a bigger number to replace it with this, it's still smaller than the right side. So a bigger number gave us a smaller, it's still smaller than the right side. So we go backwards and we say, okay, this must be true. So we follow this up, all the way up, skip some steps, and we say that 33 to the 6th is bigger than 63 to the 5th. And that's our final answer.